It is always good that our dear viewers, you have continued supporting this YouTube channel and the Facebook page. Please, as you'll be watching this video, don't forget to subscribe to our YouTube channel, Zuluba Consultants, and the Facebook page, Zuluba Consultants. We really enjoy the support you are providing to us. And in this video, let us see what we can learn together. Let's start by analyzing this graph on the rate of chemical reaction and see some of the points we can learn from this. So this graph is demonstrating how the products are being produced as the time is moving. So from here you can see that there are two situations, A and B. Now you note at the start of this graph, the graph here and here, it is sharp. So what does that tell us? At this time, more products were produced in less time. But what happens as the reaction is moving? When you look at here, the graph comes lower. This simply means the production in the reaction is becoming slower. When we look at the end here, it is now straight. What does that tell us? The reaction has ended. So at this time, no products are being made, although the time is moving. So at this point, the reaction has finished. Now, if you were asked which of the two reactions is faster, so you'll note that reaction A is faster than reaction B. Why do we say so? Well, when you look at a given time, let's say at this time, you'll note that reaction A will produce this given amount of product, while reaction B will produce this given amount of product. So here, the amount of product is more than what is here. That's why we are saying A is faster than B. So this is a graph to show the reaction when it is producing. And if you want to demonstrate the reaction for the reactants, the graph is the opposite of this one. So if this graph was for the reactants, the graph will be something like that. So let us see now how you can plot a graph with the example which we have been given. The example reads, calcium carbonate when heated undergoes thermal decomposition to form calcium oxide and carbon dioxide. The loss of mass during the reaction was measured for two different reactions. So the table there, this table illustrates how the loss of mass for two different reactions was. So the A part is asking us to plot the results on the graph for A and B. So let us see step by step what can help us to plot these results. So when you have been given data in form of a table, the first thing you need to do is to choose the suitable scale for each axis. So when you look at the time interval there, you look at it and you'll note that it was measured every after 60 seconds. So you can decide that every 2 centimeters on your graph will be equal to 60 seconds. What of the mass? When you look at the mass, it is ranging from 11 to 50. So if we say every 2 centimeters is equal to 10 grams. That will be good for us to show the mass loss. So let's see how we will use those scales and draw the graph. So as I said, every 2 centimeter in my scale here is representing 60 seconds. So there is 60, 120, 180, 240, 300, 360, 420 and 480. Then on the mass loss, which is the other axis, every interval is divided by 10. So 10, 20, 30, 40 and 60. So using the data now, you correspond the information. We'll see a very beautiful graph like this one coming out. So if you draw a very beautiful graph like this one, you need to indicate that this is for A and this is for B, which I have done in the key provided here. Remember we said when a graph is focusing on the reactants, the graph goes in this direction, and this is what we have noticed. This graph is focusing on the reactants, and it is showing how the reactants were reduced by mass. So let's go to question B. Which of the two reactions was the fastest? Suggest the reason for your answer. So here you need to see which one has the sharper curve. So you'll notice that reaction B has a sharper curve than reaction A. And what could be the reason? Well, the reason for this is that reaction B was heated more slightly than reaction A. The other question which we need now to answer is, what was the mass loss for reaction B after 30 seconds? Now, on the graph, that's where you can find the answer for this question. So we'll go to the graph, and the midpoint between 60 and 0, that is where 30 is. So I've drawn this line going upwards to show, and it needs to touch where reaction B is. Then it goes to the mass loss. So for us to get the mass loss of the reaction for B after 30 seconds, we need to know the original mass, then we'll subtract the mass at 30 seconds. So the original mass is 50 grams. Then at 30 seconds, the mass was at 42. So we'll say 50 minus 42 will get 8. So 8 grams is the mass loss after 30 seconds. Now note this. This question can be twisted a little bit. If we ask that what was the mass of reaction B after 30 seconds, the answer changes. In that case, you'll say it was 42 grams. It is different from what was the mass loss. Hope you get that point, dear learners. So the other question is, after what time did reaction A lose 25 grams of the mass? So 25 is basically half of 50. So what are we going to do? We are going to go on the graph for the mass loss and go where 25 is. Then we'll draw a straight line to reach reaction A, then there it should go downwards. So you notice that it is telling us that it's at this point, that's when the mass was the mass loss of 25 grams happened. So what's the time here? Very likely this time is 150 seconds. So after 150 seconds, that's when reaction A had lost 25. We hope that you enjoyed this video, and please don't forget to subscribe to the YouTube channel, that is Zuluba Consultants, and click the notification bell so that every time we post the video, you are able to see that we have posted the video. Not only that, you can also follow us on Facebook, Zuluba Consultants, for this and more videos.